The company is set on 3-story main office building. There are no remote users. There is one wiring closet on each floor. Each closet is connected to the ground floor wiring closet via fiber cable. There are several departments of the company. The departments included are Information Technology Department, R&D Department, Shipping and Receiving Department, Manufacturing Department, and also Sales Department. All the departments have their own network requirement to meet the needs of each of the users. The project is to design a wireless network using simulation software or network diagram tool for a small company. The design will be in form of a network diagram using simulation software or network diagram tools that should include network devices. An analysis of the design and simulated wireless technology will be presented in this report, which includes the explanation of hardware placement, hardware device choices, topology choice, and overall wireless infrastructure decisions. After the design and all of its technology were explained, a detailed result analysis after the executed simulation will be explained further throughout this report. These are important to make sure that the simulations are valid and all of the decisions made on the wireless network are relevant to use suit to the company's requirements and needs. Throughout the project execution, there are some problems that occurred during this project. Firstly, there is no remote users exist within the network. This makes it harder for the users from outside of the network to access any important information, especially when the users need the information when they are outside of their office. Secondly, wireless access points on the first level are overlapping. This can possibly cause a delay and a reduce of connection speed when accessing the network because there are some collisions between one access point to the another. Thirdly, there is no additional network for the visitors. Every company has a visitor or client that went to the company. So if the client or visitors cannot access the network, it can make it harder to do an important task, especially when dealing with clients. There are a few objectives that would be expected to be achieved during the completion of this project. One of the objectives is to create remote users on the network. Next is to create an effective wireless access point on each of the company's floor. And last but not least, to create the necessary amount of network access points for the visitors. This project enables the network administrator to properly design and plan a stable and reliable network for a small company. As information technology is exponentially growing from day to day, the requirements of getting a stable and high-speed network is a must to meet the needs of the users when accessing information. So this project plays an important role to ensure a stable and trusted environment can truly be achieved suited to the user's needs.
Assalamualaikum warahmatullahi wabarakatuh. My name is NURHIDAYAH binti LAJIS and I'll be presenting Chapter 2, Literature Review. So, review of WLAN technologies. There are three, I'll be explaining three. There is infrared technology, spectrum technology, and UHF narrowband technology. Review of WLAN technologies. WLAN stands for Wireless Local Area Network. It also called Local Area Wireless Network. In WLAN, a mobile user can connect to a local area network through a wireless connection. The IEEE 802.11 is one of the standards that defines the technology for wireless LANs. It can be constructed in either of the two modes, which are ad hoc and infrastructure. The ad hoc mode consists of peer-to-peer direct connections between clients where no intermediate hardware components are involved. The infrastructure mode of WLAN uses a central device called a wireless access point (AP), where all clients are connected. For infrared technology, direct beam of line of sight and diffuse beam are the two types of infrared WLAN solutions. It uses reflected rays with direct beam technology, which have higher data rates. And UHF narrowband technology. The benefit of this technology is that it has the longest range and it is inexpensive for large sites with low to medium throughput requirements. Spectrum technology. The spectrum distributes transmission power across the whole spectrum that can be used. As a result, even when bandwidth efficiency fails, reliability, integrity, and security rises. For review of hardware for VLAN, an access point AP is an essential component of a wireless network's infrastructure. They project a Wi-Fi signal to a specific area and allows various devices such as computers, smartphones, and tablets to connect to Wi-Fi. Wireless LAN controller (WLC) are access point managers that are mounted to a server rack. A network switch is a piece of equipment that connects all network devices together. Review of software for VLAN. DDWRT is a wireless router and access point firmware based on Linux. NPFSense. The PFSense operating system is a free and open source router and firewall. Thank you, and on to the next slide.
Alright, so Assalamualaikum and good day. So my name is KHAIRUL bin ZAMRI. So now I will present the third part of our project, which is wireless LAN design. Right, so the first part is network requirements. So every network have their own set of requirements that has to be met to ensure that the network is reliable and can determine the actual limit of the network. So it is important in real life. It is important to make some requirements based on the needs of the users of the network. Right. So for our project, there are a few of network requirements that has to be met. So the requirements, they consist and divided into several floors: ground floor, first floor, and second floor. So the first is ground floor. As you can see here, this is the table of the ground floor requirements. So they have 6 requirements altogether, and these parameters are the same as the other floor. So the signal strength, the first is signal strength, at least we set as negative 70.0 dBm. So this is because we want to maximize the signal strength as much as possible to ensure that the, the connection can be established successfully. So the second is the signal to noise ratio. At least we have set at 15.0 dB, and the data rate we have set at least 6 megabit per second, because of we want to test we want to make sure that the packets and the information can be transferred successfully and the connection will be established. So the number of access point on ground floor, we have set at least 4 access point, because every floor has their own functions and have their own users, the number of users connected to it. So for the ground floor, we have set at least 4 access point that we have installed. So the ping rotary time at most 200 millisecond, and the packet loss at most 5%. And these are the first floor network requirements. So the difference is the data rate and also the number of access point. So the first floor, they have a few departments that are important in the floor. So the data rate we have set at least 12 megabit per second, and also the number access point at least 5 altogether, because they have a lot of departments there and a lot of users are connected to it. So we have set the network requirements is 12 Mbps and 5 number access point at least in the first floor. And the second floor, the data rate and number access point, the data rate is 10 Mbps and the number of access point we have set at least 8 because they have a much important department in there, which is administrative and finance. They are also important in organization. So it is important to have a strong connection in that floor. So we have set the access point at least 8 access point. Okay, so second is the network capacity. So every network have and every floors have a different set of the number of users or number of devices they connected in the network, right? It is important. Not all floors can be set with the same number of users. So at the ground floor, we have set to laptop in smartphone with 20 number of users maximum. And at the first floor is 8 and the second floor is 25. So as you can see here, we have set to 25 users in second floor because as I mentioned earlier, they have a much important uh, department in there. So we need to have a stronger connection and there are more users connected to it. So because they are much important department in the administrative and finance. So the coverage areas. So every floor have a different coverage area, and the coverage area is measured in meter square. So these are the table of the coverage area that we have planned and we have designed to each of the floors. So the ground floor is 3,900 meter square, and the first floor is 4,200 meter square, and second floor is 3,800 meter square. So the floor plan. Okay, so every network, beside of architecture, we know that architectural site have their own floor plan. So in the network, we have a floor plan to determine where the access point should be installed. So as you can see here is the diagram. This is the floor plan of the ground floor. We have approximately installed about 9 access points here in the floor plan. On each room, we have installed the access point because we didn't want to uh, one room didn't have connection, one room have a connection. No, we have separate. We divided equally into each floor, right? Except the toilet, all right? So the floor plan in the first floor, that is the ground floor. This is the first floor. So the first floor, we have installed approximately about 9 or so access point here. This is the floor plan only. The access point will be increasing and decreasing depending on the situation. So as you can see here, as usual, each of the floors and each of the sites we have installed access point in there. So because we need to make sure that all employees have a set of coverage included in there. These are the second floor. These are the same, right? So these are the access point information that we have set. Actually, this project are simulation project. We conduct a simulation to measure the network performance of the network design. So these are the access point information that copes with all of the floor access point. This information are basically the same of all floors. So actually we have used Cisco LATPT or lightweight access point. And the SSID is ground floor is floor 1 AP, first floor is floor 2 AP, floor 3, second floor is floor 3 AP. So we have set the radio channel 1 at maximum client is 10, speed is 100 Mbps, and standard IEEE to 11B. So we have set the WFA to PSK and also software and The IP address is 10.0.0.12, and the range is we have scoped to 140 meters. These are the access point information. So these are the logical network diagram. So basically, in the logical network diagram, we have set around like 10 access point, and each of the access point connected with several laptops or several smartphones in there, right? And connected with one server. It's one server. Server is function is to provide the DHCP connection towards all of the devices that connected to the access point. Each of the access point. So these are the logical network diagram. We have used DHCP to determine all of the IP address automatically without it assigning manually IP address. So the lastly is special request and consideration. We have set a special consideration or special request that we have done. So there is one, which is the network has working without any help of Cisco WLC. Cisco WLC is a one of the Cisco device that called wireless LAN controller that considerably actually WLC Cisco device is actually needed for assigning a wireless LAN SSID to each of the wireless access point. The model that supposedly be used is 2504, but we don't um without any help of the Cisco WLC, the network is actually working. Okay, because the actual design is they have need to Cisco WLC. Without WLC, the SSID and the information the wireless access point cannot be assigned. But for some reason, the network has been working without any help Cisco WLC. Because what? Because we want to avoid unnecessary errors when deploying an access point and deploying WLC, because setup of WLC is become much harder. And the network testing result and the simulation will be explained further in the next chapter.
Assalamualaikum. My name is Muhammad HAZMAN HAIKAL bin NIZAM. For my part, I would like to demonstrate to you the simulation from this wireless network topology to test or evaluate the network performance. As we can see, we implement the real-world network topology used by company. There are 4 different types of device used, which are server, switch, access point, and also the laptop or smartphone. As you can see in this topology, we implement different kind of switch at their floor, which we have switch 1, switch 2, and switch 3 at different floor. So with this, it prevent overlap on the network. Plus, we also implement free access point for the guests at the ground floor. So, first we like to test it is free or not by using the smartphone. As you can see, it connect directly to free access point without any password or SSID needed. To test the network performance, we use 2 command which are ping and also the tracer. By doing this, we able to evaluate the packet loss, latency, and also network jitter. Let's test it. We will ping laptop 1 to laptop 3 at the same floor, but different access point, and also to laptop 1 to first floor, which is laptop 7, and laptop 1 to the laptop 17. It will be the same to the other floor. Let's go. This is the simple command where it send 4 package and receive 4 package to make it the super hard. We can send as many package as we want, like 100, or I will go to 10. So it will test with 10 packet transmit to the laptop 3. As you can see, the result packet loss are 0. It receives 10 and it send 10 and receive 10. Let's try ping to say first floor, which is laptop 7. It transmit the data, the package, and also for the packet loss, 0 packet loss for 10 package. How about the next floor? The result also maintain 0 packet loss. Next, we will go to the laptop 7. Ping it with the laptop 1, 10, and also the 7. As you can see, the result maintained to be 0 packet loss for 10 packet transmit for the first floor, and the next will be go to the third floor. As the result, in the second floor, it maintained 0 packet loss, where we test for the network packet loss performance. So next will be go to the latency. We'll go to the first floor using the trace set command, ping with the floor. As you can see, it low for the 150 millisecond, where it can be considered the grade 1. Let's test it to the next. It seemed to be low than 150, which is good latency or great latency, because 150 millisecond good latency, and 20 millimeter second is considered to be great. Next, we will go to the next floor, first floor. The result maintained to be lower than 150. And this is shown in the second floor. It's considered a good latency for this network topology. For the last one, will be use the jitter calculation to calculate the network jitter. The command are still same, which is a ping IP address. We will try for the first floor, laptop 1. For first floor, it's go to 14.67 millisecond. And the last, which is the second floor, it 42.78 millisecond. So for the network jitter, it should not be 150 millisecond or above to consider it good quality of the service. Next, we will try with the second floor. It maintained to below the 100 millisecond. It's considered good network jitter for this network topology. And the last, we will try the second floor. And the result show all this device goes to below 100 millisecond, and it show that this topology good to use for the company.
To conclude, the objectives of this project are achieved. Based on the simulation conducted, the network administrators are able to allow more remote users on the network. This upgrade provides an easier solution for the users from outside the network to have access to information within the company. The users are finally able to obtain certain data needed anytime and anywhere, even outside the company. Furthermore, there will no longer be data delay happening within the network, as it is fixed throughout this network simulation project. Hence, the users within the company are able to use a stable and fast network, which increases the productivity of the users and the work is done efficiently. Besides, there are enough additional network provided to the visitors and clients of the company. This allows the visitors to comfortably access the internet and makes them feel welcome to the company. Hence, it is a great deal to the company, as users' feedback can uplift the name of the company and allow them to grow. Every problem has a better solution, and so is this project. There are a few more better recommendations and future works need to be done to ensure that this project could go better in the future. This project may be better if it can utilize any Cisco devices in which this project are unable to implement the network with Cisco Wireless LAN Controller 2504. It is important to allow the connection of devices towards the wireless application protocol in order to have higher precision in network distribution around the office. Another recommendation and future work that can be done is to either add more access points within one office or to distribute the access points more accurately. This is due to the reason that the internet does not fully cover some area within the building. An example can be observed on the first floor, where the hallway, stairs, and certain rooms are not connected to the internet. It is important for the users to have continuous connectivity towards the internet, regardless of where they go. Hence, highly accurate network distribution is recommended to be done in the nearest future.